Okay, so the first talk this morning will be Myrvold, and he's going to talk about whether the laws of classical physics are plausibly Humean.
Okay, thanks, Matt. First of all, I'd like to thank other organizers of the conference for putting together such a great group of people. The main idea of the conference was statuses. We wouldn't be here, I think. We might be here, but we'd be in a very different conference if it weren't for him. And I would like to thank Melissa and the undergrad students who were involved in the organization, because really everything that has happened this weekend is largely due to them.
Yeah.
And I'd also like to thank the other speakers from yesterday, because a lot of what I'm going to say was actually touched, presaged in things that other people said. By the way, can you hear me fine? I don't want to stay by the mic if I don't have to. I'm okay with this headache. Okay. All right. So the title of my talk is a little bit different from what's on the program. It's a little bit more computational. Metaphysics without physics is the topic of my talk. And I'll start with a quote that some of you will probably recognize. I too lack sympathy for metaphysics, though not in general. Only for pre-Kantian metaphysics, and then only if practiced after Kant. Who is it? Von Frost. Von Frost, yes. In this quotation, and in many other places, including in the empirical stance, Von Frost compares the revival of metaphysics in the latter decades of the 20th century to pre-Kantian dogmatic metaphysics. And I think that's a bit unfair. And I think it's unfair because the pre-Kantian dogmatic metaphysicians were largely operating in contact with the science of their time, and a large part of the enterprise was to try to give a priori grounds for what Newton and others had discovered empirically. And I'm struck when I think of the canonical philosophers that we assigned in our intro philosophy classes, pre-Socratics, Plato, Aristotle, etc., through the modern period, through the 20th century. For the most of that history, the people doing metaphysics are operating in close contact with the science of their time, until you get to the 20th century, when it becomes a subspecialty, philosophy of science, philosophy of physics. And what I want to claim is that the metaphysics revival in the latter half of the 20th century did and does proceed largely without any contact of the science of the day. And that might be surprising to some people because, of course, we're all naturalists these days. And everybody says, we should respect science, respect physics. And if you look at the literature, there's occasional references to elementary particles, sometimes to special relativity. But it strikes me as largely superficial. I want to illustrate my claim with reference to the figure who's probably most instrumental in that revival of metaphysics, which is David K. Lewis. So, another quote. Here's David Lewis, 1986. I'm not ready to take lessons in ontology from quantum physics as it now is. Now, Lewis's complaint had to do with actually the same sort of thing that Sean was complaining about yesterday, the way that most physicists and some philosophers were talking about quantum physics. So that line is, that quote continues. First, I must see how it looks when it's purified of instrumentalist frivolity, and dares to say something not just about poetry readings, but about the constitution of the world. And when it is purified of double-thinking deviant logic, and most of all, when it is purified of supernatural tales about the power of the observant mind to make things jump. Only then would he take ontological lessons from it, which is fair, and I should think correct. But if you're a metaphysician in the 1980s and the best physical theory is quantum mechanics or some kind of quantum physics, and presentations of it tend to be, full of instrumentalist frivolity, what do? Well, one thing you can do, and I actually think that this is basically the only thing a responsible metaphysician could do, is ask yourself, well, how can I purify this theory of instrumentalist frivolity? And that's exactly what John Stuart Bell did. Because he was interested in taking ontological lessons from contemporary physics. And I'm entirely in agreement with what Tim said yesterday. Greatest philosopher of physics of the latter half of the 20th century was John Stuart Bell. But maybe, suppose you're not up to that task. Maybe when you start looking at the literature, you start to get kind of lost. Another thing a responsible metaphysician to do is, okay, I'm just going to suspend metaphysical inquiry until someone else does this. But that's not what Davis Lewis did. He spent a lot of time advancing a picture, which he called Humean supervenience, which he claims is inspired by classical physics. Most of you are familiar with the basic idea of that. I'm actually going to quote two extended presentations of it. This is from that same introduction to his Philosophical Papers, Volume 2. What is human supervenience? It's the doctrine that all there is to the world is a vast mosaic of local matters of particular fact. Just one little thing and then another. We have geometry, a system of external relations of spatial temporal points, maybe points of space-time itself, maybe point-sized bits of matter, or ether or fields, maybe both. And at those points we have local quantities, perfectly natural intrinsic properties which need nothing bigger than a point at which to be instantiated. For short, we have an arrangement of qualities, all else supervenes on that. Then a little later we have something that is almost, but I'd say not quite, equivalent. Humean supervenience says that in a world like ours, the fundamental relations are exactly the space-time relations, distance relations, both space-like and time-like, perhaps also occupancy relations between point-sized things and space-time points. It says that in a world like ours, the fundamental properties are local quantities, perfectly natural intrinsic properties of points, or point size occupies the points. Therefore, it says that all else supervenes on the spatio-temporal arrangement of local quantities throughout all of its history, past, present, and future. And there's where he explicitly says this picture is inspired by classical physics. What I want to claim in the talk is that if you look at classical physics and think about how it works, the claim that this picture is actually inspired by classical physics becomes a little bit implausible. And now I'm not saying that you can't shoehorn classical physics into a picture like this. I'm actually going to suggest a way that one might do it if one were motivated to do so, though ultimately I think even that way doesn't work. And I'm not going to claim that there is no way that this picture can be made compatible with classical physics. But compatibility is a very weak relation. Lots of things are compatible with other things. I will stand by the claim that this isn't so sort of, if you think about classical physics and think about it in the kind of word, this is not the natural view you would come Well, why? Well, it's crucial to this view that everything supervenes on, perfectly natural intrinsic properties of points, and in particular, everything law-like supervenes on that. Laws for Lewis are patterns in this Humean, summaries of patterns in this Humean mosaic of things. And it's crucial for Lewis's program that those same perfectly natural intrinsic properties can be rearranged in all sorts of ways, and if they were, you would have different laws. But that means that, to attribute one of those properties to a point can't be implicitly a reference to some kind of law. Like, it can't be the sort of property that can only exist if there's certain kinds of law-like behavior. And I want to talk about what kinds of properties those might be. Okay, so that. And I want to distinguish broadly two kinds of families of properties. First, I'll call dynamics, and to ascribe a dynamic property to something is to say something about its pattern of behavior. If I say that Bill Harper is an engaging speaker, that says something about what Bill Harper does. If I say this table is hard, that says something about what happens when I touch it. So including in this things, anything that's requires some kind of law in order to make sense is an implicit reference to some kind of regularity behavior, and I include dispositions and powers. That sort of thing. I don't want to make any claim about whether these are synonyms or not. I hope the general idea. And then, on the other hand, there's other things. Sometimes the word categorical is used, and those are the sorts of things that could be real. To ascribe such a property to something carries no commitment about what it does or what regularities it participates in or what kind of laws there are. And the reason I'm talking about this is whatever the Humean supervenience base is, they're going to have to be in that latter category. And all these dynamical properties are going to have to be derivative of that. Okay. So, I said that. So what could be in a Humean world? When I think of classical physics, I think of things. I tend to think of fields and mass densities and charge densities, and especially if someone's talking about properties of space-time points, I most naturally think of fields or mass densities or charge densities. And so the question is, are any of those plausibly categorical properties? Apologies, there's a typo there. Well, I'm going to talk a little bit about what a field is. The field concept is usually, thought of as being in very nascent form in Faraday's work as topic lines of force, and was elaborated and put on a sound mathematical footing by James Clerk Maxwell. There's a nice paper by Howard Stein called "On the Notion of Field in Newton and Maxwell and Beyond," where he finds in the early pages of the Principia, where Newton is talking about forces and the different measures of forces, something that is, the seed of our concept of a gravitational field. Because Newton talks about centripetal forces, and he talks about the accelerative quantity of a centripetal force. And he says it may be referred to the place of a body as a certain efficacy diffused from the center through each of the surrounding places in order to move the bodies that are in those places. whether there's bodies there or not. There's, if I've got, say, a gravitating body, then in the space around it, there's a certain efficacy to accelerate something, whether or not there's actually something there. And inside says, okay, yeah, he's talking about what we now call gravitational fields. Now, I hope it's clear that whatever whatever categorical properties there are in the world, an efficacy to accelerate something isn't going to be that great. Right. And I think similar things can be said about electromagnetic and other fields. There are efficacies to accelerate charged particles and things like that. Okay. Digression. This particular slide isn't particularly about Humeanism. Suppose, but I think it's just if you think about the concept of field, it's something worth saying. So suppose I'm not a Humean about laws. I don't think that laws have to supervene on categorical properties. And ask, well, okay, on that kind of view, can I think of a field intensity as an intrinsic property of a point? A lot of people sort of take that for granted. Well, to be an intrinsic property of a point means I think in the way that people typically use it, the phrase these days, the way that derives from Lewis, it means that there could be a duplicate of that point, say, in another world, in which everything else is different. So in particular, if there's, take whatever electromagnetic field values at this point at this time, right? And if it's an intrinsic property of that space-time point, because I've got very fine fingers, I picked out a single space-time point when I point to it. If it is an intrinsic property of a space-time point, there could be another world in which there's a duplicate of that point, which has all the same intrinsic properties, so it has that value, and it is surrounded by points in which there's no electromagnetic field. Now, if you think of an electromagnetic field as a certain efficacy to create an acceleration, and you say, okay, what that means is if there were a charged particle whose trajectory went through that point, it would have, it would have no acceleration until it had a point, and it would have, whatever finite acceleration is appropriate to that field value at that point, and again, well, there's no such trajectory. There is no trajectory that has zero acceleration everywhere except at one point and a finite acceleration at that point. Even if you include trajectories that aren't smooth and have points, well, okay, then they don't have it might be that the acceleration is undefined at a certain point if you have an abrupt change in velocity, but there's just no possibility. It just makes no mathematical sense to talk about something having a finite acceleration only at one point. And that means that field values aren't actually intrinsic properties of points, space-time points, in the sense we usually think of it. Though, they can be local properties of points. And what I mean by local properties is intrinsic properties of arbitrary small neighborhoods of the points. So, because take any space-time point with an electromagnetic field value, take any neighborhood of it, then that field value is compatible with arbitrary states of affairs outside that neighborhood. So I think there's an interesting distinction there between intrinsic properties of space-time points and local properties of space-time points that can. I'm getting this largely from Jeremy Butterfield. That, I mean, there's an important distinction that comes about if you actually do think seriously about classical physics. Lewis, I think, tends to use local and intrinsic properties of points, interchangeably. End of digression. Okay. Okay, so what's not in a human museum? Fields, as ordinarily understood, are not. To attribute a mass to something is to say something about how it responds to forces. So masses aren't going to be these, purely natural intrinsic properties. Obviously, charges and generalizations of charge in modern particle physics. And what's left? Well, if I try to think about what a Humean world could be, and this is something that's suggested by that second quote where he's talking about occupancy relations of points, the best I can come up with is, okay, you've got some kind of space-time, and then you've got this primitive property of space-time points of being occupied or not. And that's an all or nothing thing. So, you could, so you could have, what we think of as point particles, or something like that, or there could be extended regions that are occupied, and then presumably, if there are going to be laws of motion in such a world, and it's not guaranteed, you could have, you could have a Humean world in which the pattern of occupation of points is just totally chaotic, and there's not, they're saying something about the occupation of which points are occupied in the past is virtually and entirely uninformative about the future, and there just might not be any interesting physical laws in a world like that. But if there's going to be, physical laws, anything like, let's say, classical physics, then there's going to be some continuity of these occupied regions. You're going to, you're going to at least sometimes be able to, unite them into trajectories, either of point particles or extended regions of phase. And I would say, okay, that's it. You've got space-time, you've got, a decoration of space-time which says, points are either occupied or not. And then everything else that we talk about in classical physics, fields, etc., I think would have to be regarded as devices we use to express the laws governing the motions of these points or occupied regions. So they actually wouldn't be in the fundamental ontology or in any really deep sense in the ontology at all. They would be auxiliary concepts that we use to formulate the fields. And masses and charges or things would be parameters that occur in those laws and not intrinsic properties of the bodies to which we are inclined to attribute masses or charges to. They would be extrinsic qualities of those things, and they are nothing more than parameters that we use to express the laws, which nicely form the simplest and most informative system for summarizing the motions of these things. Okay. Okay. But, so, something like this, there's just various regions of, when I try and picture this, I always picture a white background and something's black, right? Something like this, and you can, and if I had more time, I would animate them and have them move around and things like that. Okay, so imagine that I had animated them, had these things around, and two of them approach each other. What happens when two of these regions approach each other? Assuming that they actually there are regions that retain their shape and form continuous trajectories. Well, as far as the basic ontology is concerned, anything can happen. There will be worlds where they just pass right through each other. There's worlds where they evaporate when they touch each other. There's worlds where they bounce off. Anything I say about the behavior is going to have to be not intrinsic to these summaries of behavior. So in particular, this occupancy relation can't be one like when we tend to think it's impossible for two objects to occupy the same space, and if I have two occupied regions that come together, by the mere nature of the occupancy relation, they're going to collide and bounce off. And that actually is going to be, well, true at some worlds and not true in others, according to the Humean thing. It's, say a region of space-time is occupied is to say nothing at all about its dynamical behavior, if a Humean picture is right. So that, I think, would be the sort of the most viable version, as far as I can tell, of Humean supervenience. And this idea that somehow or another, this occupancy relation is, good, categorically non-dynamic one, belongs on that side, is something, it's something that's shared, I think, not just by Lewis, but by a lot of other philosophers. So I have a quote said that. Okay, actually, before I get to that quote, another digression. If I wanted to be a Humean about quantum mechanics, I would say, okay, if I thought that picture worked, then there actually is a natural extension to it, to a quantum version, because what I would do is take de Broglie's picture of, de Broglie thought of the de Broglie pilot wave theory is basically a revision of classical physics in which you have basic corpuscles, but they obey non-Newtonian laws of motion. And so, if I want to be a Humean about quantum mechanics, I would probably say something similar. The basic ontology is you've got space-time, you've got points that are occupied that form trajectories, and then the wave function would play the same role as the electromagnetic field. It would be a convenient way of summarizing the laws by which those trajectories behave, but not in fundamental ontology. Okay. All right. Okay. I just want to. So the underlying intuition, as I said, is that most of the properties we ascribe to an object are dynamic properties, which say something about how they behave. Mere occupation space is a categorical property. And that intuition is shared not only by Lewis, but by some more serious philosophers. And here I have a quotation from one of those. So we have intuition about the distinction between powers and non-powers. Take an object that is fragile and spherical. I always do this every time. So take an object that is fragile and spherical. Let us accept that both properties are actual, objective, and intrinsic. Still, there's a difference between them. Fragility, like sphericity, is always present. But unlike sphericity, fragility has a kind of dual life. It is and can be unmanifested, but it can and does manifest itself. It does not make sense to say the same thing of sphericity. It leads no dual life. So I want to talk about that. What does it mean to say that this object is spherical or almost spherical? Well, the region of space it occupies is almost spherical. Okay, fine. Well, what's it mean to say that this object is occupying this region of space rather than this cubical region of space over here? Well, it reflects light from an approximately spherical region. I touch it, okay. There's an approximately spherical region in which there are tactile sensations. If it were a helium balloon, it would be obvious that it's roughly impermeable to helium because there would be a roughly spherical region in which the helium was confined. all those things I just mentioned are dynamical properties. And I would suggest that if you think about the notion of occupation of space, both in everyday discourse and as used in physics, it's on the dynamical side. That to say something about, to say that an object occupies space, or to say of a region of space that it is occupied rather than unoccupied, is to say something about dynamical properties, to say something about how that region of space behaves with respect to other things. So this is why I said, even though I represented the candidate for a Humean version of classical mechanics and possibly quantum mechanics also, that would be the best candidate. It depends on there being this categorical occupancy relation, which is not dynamical. And I'm not saying that there could be no such relation. I'm not saying that we can't make sense of it. What I am saying is that if you think about the way the concept of objects occupying space is used in both ordinary discourse and in physics, it's on the dynamical side. Okay, I just said all that. And so I say that, yeah, I think a lot of us share that kind of intuition that it just makes sense categorically to say there's something there or there's something isn't. I'm actually worried about whether that makes sense at all. I think intuitions are dangerous things. Okay, I can't, you can't tell philosophers never ever had intuitions, but when we have them, we should treat them with care, and if possible, try to think about them and turn them into actual judgments. What I'm saying actually was said fairly early on by my favorite philosopher of the latter half of the 17th century. Bodies can be defined to be determinate quantities of extension which the omnipresent God affects with certain conditions. That they be mobile, and then he says, okay, it's not actually the region of space that's mobile because regions of space actually only have their identity with respect to other regions of space, so it doesn't make sense for them to move. But what he says is, the region that has, so different regions of space at different times have these have the following qualities, and that region, and which region it is can move around. That two sides should be unable in any part to coincide, or that they be impenetrable, and when by their motions they meet, they obstruct one another and reflected in accordance to certain laws, and that they be able to excite various perceptions of the senses and fancy and creative minds, if we prefer to be moved by that. And he says those are either bodies or indistinguishable from bodies. And actually, here he's saying that that's what bodies are. And he says that's what counts. Just being extended doesn't count. Sorry, Cartesians. There's lots of extended regions of space which are unoccupied bodies. Which of the extended regions of space are occupied by bodies? Well, the ones that have these dynamical properties. And moreover, that's all you need. You don't have to have some kind of other substrate, other than that region of space to be the bearer of such properties, says Newton. And if you think about how we attribute size and shape to things in modern physics, one difference is, Newton talks as if the region of space occupied by a body is, impenetrability is an all or nothing thing and it has precise boundaries. But that's not, I think, essential to the concept. if you said, okay, if the law isn't, just bounce back, but, that they have very little force between them when they're distant and a strong repulsive force when you get close, that would satisfy Newton's needs. And if you say, okay, things like this balloon are absolutely impenetrable, they're semi-permeable. If it were a helium balloon, we'd become aware of that because it would sit here all day and gradually, by the end of the day, the composition of gas in the balloon would be the same as, more or less the same as around here, because the helium, or actually it would deflate because it's more, it's more readily permeable with helium than to, other atmospheric gases. So, but more or less is good enough. Impenetrability, things can be impenetrable to some things and more or less impenetrable to other things. And when people talk about the size of the proton, what could that mean? Well, what they mean is how it behaves when you scatter charged particles off of it. And people publish papers with the title "The Size of the Proton," but when you read what they're actually measuring, it's the root mean squared charge radius, which has to do with the statistics of scattering charged particles off of it. And if we talk about a nucleus or an atom occupying a region of space, it really has to do with primarily with the electromagnetic properties. We talk about the size of atoms. Well, how close can you get them before they strongly repel each other? Things like that. So I want to say that in spite of all the vast changes in physics since Newton's time, the basic idea of his notion of body is something that remains that remains viable. If you said to Newton, do they have to be absolutely impenetrable? I don't know what he would have said, but what he should say is, well, no, just enough that that we know it's there. And I think actually there's a general lesson in that, is that if you're going to do metaphysics, first of all, I think you should think about contemporary science. But the metaphysical conclusions you draw should be fairly robust, at the pain of being more, being fictional. They should be fairly robust under changes of physics. And so you can ask yourselves, what kinds of features of our contemporary physics should we expect to persist? And Tim was totally explicit about that yesterday. He wasn't saying that in whatever physics we have, space-time has to be fundamental. It just has to have something that looks like this space-time now at an appropriately coarse-grained level. And I think we can be fairly confident that that future physics is going to contain something like that. I mean, if not, I actually don't know what it would mean to call it physics. And I think that Newton was correctly, Newton didn't have actually much of a theory about the composition of matter besides his decree of God. But I think he could be fairly confident that whatever future investigations revealed about the nature of bodies, there would still be regions of space which repelled things, regions of space which repelled each other when brought into close contact, and I think that remains true. And it would be a mistake, I think, if there were 18th century metaphysicians who had extended debates about, say, which bodies could be simple bodies, which were predicated on the idea that impenetrability was an all or nothing thing, and I could just talk about precisely precisely defined regions of space that bodies occupy. So, I don't think that the prospect of, even though every physical theory that we've ever had, and quite possibly every physical theory that we will ever have, is not fundamental, I don't think that that's incompatible with drawing conclusions about the nature of physical reality from those things. But we have to do it with a certain amount of caution and make sure that our conclusions could be reasonably expected to be robust under changes. And that brings me to the end. So coming back to supervenience. If there is someone who's determined on purely operative grounds to hold the supervenience, I haven't given the knockdown, drag-out argument. I haven't shown it to be self-contradictory. I haven't proven that there can't be categorical properties on which everything supervenes. Part of the reason that I haven't proven that is I have literally no idea what such properties would be like. And if I have no idea of something, I can't prove it can exist. But I do say that if you're engaged in that kind of enterprise, I'm going to construct a Humean version of Humean supervenience that is compatible with both with everyday experience in classical physics and quantum physics. You've given up any pretense of taking lessons from physics of any kind. And if you're engaged in that game, okay, fine, but I'm not going to play it. Thank you.
I've heard about a couple of the arguments to the claim that, just say, classical physics doesn't talk about intrinsic properties. One was the argument that fields can be construed as properties intrinsic to all the points in space. One thing that I worried about with that one was that you were relying on Humean the conservation principle, and I don't think there's any reason why just because you have a view that has intrinsic properties are going to necessarily endorse that principle. So I can say like a field supervenes on the values of certain values assigned to points, and just deny that that means that there's a possible world where you just have a field value at one point.
Good. Then you're rejecting Lewis's entire program of Humean supervenience. Good. Thank you. Welcome.
So like when Tim talks about Humean supervenience in his book, Metaphysics and Physics, and also I think Barry and his Humean supervenience paper, they distinguish Humean supervenience into two claims. One is a claim about the mosaic and like what fundamental reality is, and a second claim that everything like laws, counterfactuals, causation, all supervenes on that.
Right.
So I am denying the second claim,
right.
But there's another claim about what we should construe as the fundamental features, and so there's a question about fields and how we should understand that.
Right.
And I could say that fields should be understood as intrinsic features of like that assigned to points without necessarily committing myself to a claim about counterfactuals. The fact,
So
those need to be separated.
Those are two separate claims, right? And I was largely concerned with that second claim, which I think everyone should rightly reject. And so, but then there's a digression in the middle about even if you're not a Lewisian about laws, should we think suppose I think laws is primitive. Even if that's true, I would say that field values are not intrinsic properties of points, but local properties of the points.
Yeah,
so if I say, okay, it is characteristic of classical physics that the state of the world supervenes on assignments of local properties to I mean, the way I put it in one of my papers, the doctrine of separability says the state of the world supervenes on assignments of intrinsic properties to elements of arbitrarily defined coverings of the world. And that, I think, is true of classical physics. That everything in Bell's terminology, in classical physics, everything supervenes on local variables. I think that is true of classical physics.
Yeah, that's, I mean, I wasn't, can I just add this little thing also? I was worried about just the argument in the beginning where you were saying that these properties like mass and charge and the rest are intrinsic properties by saying that they're dynamical. Because I think usually when in the literature on intrinsic properties, it's really helpful to make a distinction between intrinsic versus extrinsic properties, where that's, a property that's just about an object versus, property, that's about an object's relation to other things, and intrinsic versus relational descriptions. So most people, including Stathis in the quote there, will talk about dynamical or dispositional features as intrinsic.
Okay.
But that doesn't mean that, they can't be given relational descriptions.
Right, yeah, okay, so I want to be clear about this. The background of my talk was, so the background of those remarks were, are these things that you could count as intrinsic properties? The issue was between categorical and dynamical and categorical. And if you have a Lewisian view of laws, the intrinsic properties of these space-time points have to be categorical, only on a Lewisian view of laws. Right? So if something like Lewis's picture of Humean supervenience is right, then to say something is a dynamical property is an implicit reference to the rest of the Humean mosaic. So if you have that view of laws, then the dynamical properties aren't intrinsic. However, if you don't have that view of laws, then you can say, yeah, the field values are intrinsic properties of arbitrarily small neighborhoods of points, and that's just fine. And the business about sphericity, the issue wasn't versus intrinsic versus extrinsic. It was versus dynamical, dispositional powers on one side and non-dynamic properties on the other. And what I wanted to claim that talk of the region of space that sometimes occupies falls in the dynamic side of things on any view of laws. But yeah, it's only on this Lewisian view of laws that dynamical properties can't be intrinsic.
Yeah, just on that point, so about sphericity, like I'm really sympathetic to this stuff, but it seems like the way that you characterize what it is for something to be spherical was in terms of how we can know it to be spherical, right? And non-Humean views have always had an advantage over Humean views in terms of it seems that they're more closely aligned with scientific epistemology. This is a bullet that Humeans just bite. Like we'd say that, it's, unless you commit to some kind of idealism, there's no reason to think that the way that we, through the conditions of accessibility of an object, right, to determine what the object is. So as I say, I'm really sympathetic, but this, one mustn't confuse how it is that we know objects with obviously with how it is that they are. And this is an epistemic bullet that Humeans are just willing to bite. I mean, I can't make sense of it, but it is a bullet that they're willing to bite.
Good. I'm glad you put that. You said that. That's speak to the side I actually had and took out. So yeah, I wasn't really talking about how do we know it, but I was talking about assertability conditions. Mm-hmm. And I actually think that the meaning of sentences or predicates is actually inherently tied up with assertability conditions. So if someone tells me actually no, this isn't spherical, it's not here. It's actually cubical and it's here, but it manifests all its dynamical properties over here in the spherical region of space. I don't know what that could mean. What would single out this region of space as the region occupied that object? If I have a region of space that's not dynamically distinguished in any way, but I say, well, that's where it really is. I've actually, we've got. I mean, I just. I can't. I don't know what to say because there's a string of English words that I can attach no meaning to. So and so that's why I said I have not refuted Humean supervenience. If someone tells me that actually the basic properties of the world are these categorical properties that Wayne you can't grasp, you have no idea what they're like. There's nothing. None of the words in your vocabulary refer to these things. You have no idea about them. But that's what everything supervenes on. I can't refute that because I have no idea what that would mean. And that's what the qualification at the end. I have not refuted Humean supervenience. If on a priori grounds you thought the world had to be that way, and oddly enough Lewis wasn't one of those because he claims it's a contingent thesis, then you could, without actually contradicting yourself, saying, yeah, there's this supervenient space of properties that are nothing at all like the properties that appear either in physics or in our ordinary discourse. I can't tell you what they are. If you don't have epistemic access to them, but that's what everything supervenes on. That's not an actually contradictory sentence. But I've lost. At that point, I just lose interest.
Can I say something? I don't want to jump the queue. If there are other people who want to speak on the same point, I'm happy to wait. But I mean, this issue of the nature of properties is independent of the Humean supervenience or not. So Armstrong is a categoricalist, and he doesn't buy into supervenience. So it's an issue about how we think about properties. And it's an independent issue in many senses. And the issue, it seems to me, is how we individuate properties. And there is this old argument that take a triangle. Being a triangle is a dispositional property because were I to count the sides, I would count them 3. But that's a silly argument produced by very serious philosophers, whom I respect a lot better than I am and lots of other people. But the point is that it's one thing to say what a property is, it's another thing to say what the property does in virtue of what it is. So no one would deny that by virtue of having some properties which we call categorical, for want of a better term, an entity has various dispositions or powers to behave in a certain way, but identifying the property with the powers is a step which needs a further argument. And I haven't seen a good argument, not by you now, but other people. It's mostly an epistemological argument, which I think Kate said that. The argument that we know the properties via how they affect on us or the effects on other things, therefore the property is the causal role. But there's a gap there. The property can be something else and have a causal role. And lots of people think that there is something else which is a categorical basis for want of a better term. And it seems to me that part of the argument at the end of this paper that you cited was that there is this famous ultimate argument for powers, elementary physics, elementary particle physics, individuates entities according to the causal role, therefore properties are powers. But part of the argument in this paper was that there are other ways to individuate elementary properties like spin, charge, and mass via symmetries. And it's not clear to me, at least, that this way to individuate is dynamic as opposed to what we call vaguely categorical. And I said the jury is still out. I mean, we don't want to commit ourselves.
Good. Thank you. I mean, I didn't need to be giving an epistemological argument. I was first thinking about, what I wanted to do is, ask what do we mean when we say that this region of space, rather than another region of space, is occupied by the balloon. What is the distinction between an occupied region of space and an unoccupied region of space? And I do claim that that is a dynamical thing. you know, if you say, okay, you know, that's just has, you know, there's this primitive relation of occupancy, and you know, this just is, you know, happens to be how we get access to it by the dynamical properties. That, I mean, here's what I know what Newton would say. You know, like just up to that. You know, well, if you strip away all the dynamical properties, you've also stripped away occupancy. Right? Like, you know, there becomes no distinction between occupied regions of space and unoccupied regions of space. We can talk more, because I don't expect that to be entirely convincing to you. Okay, that I'm on Newton's side with that one.
Did you carry to yours or still here with that?
No, I haven't. I went to the back.
So the next one was Robert, I think.
Thanks. That was I found that a very compelling talk. I just wanted to add a note in what I think is supportive of it. I mean, you mentioned Lewis's obliviousness to his willful obliviousness to quantum mechanics, and apparently oblivious to Newtonian mechanics as well. And you could also say that he's oblivious to almost everything in between. But on this particular point, and that is the willingness to take for granted the idea that there's something epistemically and ontologically basic about spatial relations. I mean, anyone after the mid-19th century should have known that that's a highly theoretical construct that's based on a lot of physical assumptions which eventually, in fact, were sort of completely undermined by the critique by Einstein. And nobody in the 1980s should be treating spatial relations as some sort of ontological primitive. I mean, if I do classical mechanics, I'll do that, but that's because I don't pretend to be doing metaphysics. I pretend to have a theory, a useful but no longer considered true theory about how bodies move and how gravity works, and I can use that for sending people to the moon and whatnot. But to be talking about a fundamental ontology in terms that, you know, anyone after 1870 should have thought were highly naive, just seems, well, it's what we all think. It's what the worst caricature of what metaphysicians do.
Thank you for that. Yeah, I'm entirely in agreement. You know, thank you for reminding me that, you know, I actually also think that space-time relations are you know, dynamic.
Thanks a lot, Wayne. I really enjoyed that. I really like your distinction between dynamic and categorical. I just had a comment and then a question. So the comment just has to do with some of the discussion about this. I don't think the only argument for your dynamical view of properties is epistemical. That's certainly one of the arguments. But another argument is just a kind of argument from parsimony or something, to the effect that once you think about these dynamical properties in dispositional terms, you didn't commit yourself to saying that they're dispositional, but you said a dispositional view could satisfy this dynamical conception. Then there's really nothing else left for some extra posit, like a quiddity or something to do, right, in terms of identifying the property. So, of course, that leads to its own, you know, you have to be willing to accept something like a power, and some people aren't willing to do that. So that leads to its own interesting mysteries, but there's also an ontological. But, so that's just a comment. The question is really Alyssa's question, which I have, but I just wanted to pull out your answer a little bit further. So the temptation, based on what you said, is to sort of conflate the idea of intrinsic properties with categorical properties, and to take dynamical properties to be non-intrinsic.
Well, right? If you have a Humean view, I guess what you might want to make it clear. On the Humean view of roles, of laws, the dynamical properties are going to have to be implicit references to the Humean view of and on that view will be non-intrinsic. On a same view of laws, there could be intrinsic dynamical properties.
Right. So just okay, good. So just so I can make sure that I understand exactly what you're saying. So if we imagine, now this may not be a possible world, but if we imagine a possible world with say one space-time point,
right?
Then you might want to say that it has intrinsic properties. Or if I take it what you're saying on the Humean view, we might be unable to say anything about its properties because there are no laws in that world. There are no regularities that could then be recognized
So
as
you wouldn't
laws.
have any, you couldn't attach any dynamical properties to it. I mean, if it persists in time, I guess, you know, there could be, everything. So you said one space-time point. It's hard to see that there could be interesting Humean laws in such a
Well, exactly. So that was pulling out what you were saying about how this is going to work in the community.
Yeah.
Right.
Yeah.
Okay, the next one is at the back, sitting next to Joe.
Yeah,
No question.
I wanted to ask.
You're next, but there was a question from the lady sitting next to you.
That's
Jessica,
right.
sorry.
Yes, thank you. Wayne, thanks, that was really interesting. I would just like, I just want to sort of, maybe, not exactly defend Lewis, but try to say how I think about what he's doing, right? Which maybe renders what he's doing a little bit more sensible, right? So, you know, you have to focus on the Humean supervenience, right? So he's operating from a position where he's taking seriously the idea that there's no irreducible modality. Similarly, no irreducible dispositionality, which is not to say that he's not going to want to accommodate modal claims, dispositional claims. Of course he does. But his game is to say, okay, let's take the idea seriously that there is no irreducible dispositionality, dispositions are reduced to some kind of categorical features of reality, and see if we can get back everything else, including dispositionality. So that's one point, which will come back later, but the sense in which he thinks the view is inspired by classical physics, I think also is specifically reflecting that. This is reflecting not so much that classical physics says that the fundamental properties are categorical and not dispositional, but rather that from the position of classical mechanics or physics, there are no irreducibly global features of reality. So the quantum mechanical picture is one where, you know, you might have these sort of, you know, global correlations and so on. Classical physics, at least, is not saying that. So that's the sense in which he's saying his view is inspired by classical physics, not that he's incorrectly claiming that, you know, classical physics just posits non-dispositional fundamental features of reality. So that's one thing, but I just want to say that let's see, where does it go? The idea is that he's going to try and be naturalist enough to accommodate that. So he is accommodating that to some extent. And then again, he's going to, down the line, get you back those dynamic features after he gets his laws and associated counterfactors. So I think really the question here in the background is what would it take for metaphysical theory to properly accommodate some version of physics? You know, he's going to say, look, it's not non-negotiable that I have to follow kind of a face value understanding of the fundamental properties as being dispositional. You know, I'm going to get you back to dispositions. It's going to turn out those are not fundamental.
Yeah, so good. Thank you. Yeah, so I think I agree with pretty much everything you said. Yeah, so I mean, it certainly is true of classical physics that you have separability. You know, everything supervenes on assignments of on local matters of fact. I think that is true of classical physics. No irreducibly global things. That's right. And then like if you start out with I mean that's what I see Lewis's project as. Starting out with the a priori idea that everything's going to have to, everything dispositional is going to have to supervene on something categorical, even if that something categorical is something that I have to invent because it's not anything that occurs in ordinary discourse or in physics. That part I was claiming is, cannot plausibly be claimed to be inspired by classical physics. Even though you might try to shoehorn classical physics into that, into that kind of mold. And I absolutely agree that we don't have to take the formula, if we look at physics as a formula, we don't have to take it at face value. For example, Newton formulates his physics in terms of absolute space as if there's this notion of absolute rest. And I think that most people agree that if you actually think about the role that is playing in the theory, it actually isn't playing an essential role. And as Howard Stein put it, the true space-time of Newtonian dynamics is the space-time that he called Newtonian space. He called it Newtonian space-time, I think, and we now call Galilean space-time. So yeah. But I think there's that enterprise of not taking the presentation of physics at its face value and actually looking at the role the concepts play in it. And then there's the project of starting with the conception of how things have to be and trying to cram the physics into it. And I'm happy with the former and not with the latter. Yeah.
I mean, so following up just on Carrie's kind of taxonomy of ways of doing metaphysics, really Lewis says, and he's very explicit about this, that he's more in the second camp, where he's just really interested in the viability or the possibility of this kind of stance. From that perspective, where you're just looking, what is a minimal basis that you can get away with? That's a very interesting project, and even if it requires some twisting or manipulating things in a way that might feel slightly unnatural, with respect to accommodation in science or experience or anything else, it's still, I think, a really valuable project. And I think it's just, look, this is Lewis's strategy. He is trying to figure out what is the minimal basis by which I could get the rest of the world back. And like I said, I think this is illuminating because, for example, when you're doing your scientific theorizing, you're trying to figure out how should I interpret this theory, at least you know what is required. You could go this way. You could go this way, put bracketing any further concerns that we have with the theory. Do you want to go there, or do you want to do something that requires more ontology, more ideology, in order to accommodate things more naturally? I like this latter idea. I'm happy to have more ontology. Irreducible dispositions are fine with me, and so on. But suppose you hate them. Suppose you have independent reason to think them problematic from some point of view. Well, hey, Lewis has given you, scientists or philosopher of science, a way of making sense of that. Right? That's his project. And I'm not really sure what the complaint is supposed to be with respect to this. The viability of that kind of project and its potential usefulness, even for someone who doesn't follow him in his presuppositions.
Yeah, so I guess I can see that kind of project, and I'm not terribly interested in it. You expressed it in what some people might want, what someone else wants. I don't think what there is in the world has much to do with what I want and don't want.
Well, we're not at the point of inquiry where we should be dogmatic either way. What we should be doing, I think, is just sort of saying, okay, what are the various ways in which we can kind of get back the world? If you're interested in what kind of things there are in the world, I agree we shouldn't be dogmatic enough at all. Yeah. And we also shouldn't engage in wishful thinking. Like, I might prefer an ontology of the desert, and someone else might prefer an ontology of the jungle. But I think we have very good reasons to believe that what the world is like has little to do with what we prefer it to be like. And if I want to know what the world is like, I know no other means of doing it except the empirical inquiry, the methods of science. But look, the empirical methods of science are also bringing to bear theoretical desiderata and considerations like parsimony and everything else. It's not a matter of what we like, right? It's a matter of, you have to look at all these different considerations. For example, Hume argued at length that there couldn't be any irreducible modality, et cetera, from an empiricist point of view. So
So I think that actually comes to like a key point about scientific methodology. So there's this, got a paper about this which I've never been happy with that's in fact published. But there's this picture that empirical evidence leads to. There's a picture of how science works, and which is empirical evidence leaves theory choice drastically underdetermined, and then we bring in extra empirical theoretical virtues to make that choice. I actually think that that's not how scientific inference works. I have a paper called a Bayesian account of virtual unification, where I say that, argue that, some of the things that look like, appeals to extra empirical theoretical virtues, such as simplicity with regards to the Copernican system, can actually be recast as empirical arguments. And I think that, I think it's a mistake to think that extra empirical virtues like simplicity and things like that are actually legitimate grounds for believing a theory, rather than making choices like, okay, this is the theory I'm going to work on, or this is the theory I'm going to pursue. But that would be an entire another talk.
okay, I look forward to that.
Sexual was next.
Yeah, I wanted to ask you if I understand you by rephrasing what you say in a language which I can.
I'm sorry, can you speak
I
a little
wanted
bit?
to see if I understand you by
Okay.
rephrasing what you say in my
Okay.
language. I
Yeah.
don't know if it's correct, but you see, it seems to me that the problem of Lewis is that the distinction between facts and laws is not so easy to do. And you would like to observe facts and then laws, which are whatever they are. But you see, if I say this table is solid, then of course, if I don't appeal to laws, it's not sure what the meaning of solid means. Either I say, well, I can burn it, or, this thing, or something like that. But then, of course, you would like to go to the microscopic physics to express these facts. The first problem, of course, the people who got the picture of the microscopic physics were trying to find out the laws of nature, which previously did not exist. And the second problem is then, even then, if I understand you correctly, it's not so easy to express what the electromagnetic field is without appealing to laws, because the meaning of the field is inside the law. I don't know if I understood it. It seemed to me that the metaphysics or the view that Lewis proposes is not really classical, it's pre-classical. It's really trying to extend to everything the common sensical view of the world that we have with chairs, tables, and so on. And I think Newton has shown that that's impossible.
I think that's a fair summary, yeah.
Okay, and Colin's next.
Yeah, so I don't want to try to defend Lewis's project, but I sort of got uneasy at the ways you were talking about matter, and you have a quote up from Newton which made him sound like a sort of an Aristotelian realist, and then you said, and basically we've got the same picture all the way through to today. And that seems to me dramatically in tension with the stuff that we were hearing from Tim and John yesterday. And so my reaction at the end of the talk was like, well, too quick, because you're trying to shoehorn the world into basically a common sense image. Now, unlike Lewis, your common sense image of the world is full of powers and dispositions, and Lewis doesn't like those things. But basically, you've got exactly the same thing. You've got a nice three-dimensional, existing over time mosaic of objects full of powers and their interactions. And how does that match with really quantum field theory? And shouldn't you be a little bit less bold in your assertions about the disposition of the continuing importance of this kind of dispositional and powers talk in the context of 20th century physics?
Say a little more about this tension, because I didn't see what I was saying as being in tension with what Tim and Jean were saying. A lot of the emphasis of Tim's talk was that, whatever else physics has in the world, it's got to have something that plays roughly the role of these three-dimensional objects and things that pointers that you can touch or reflect light or something like that. Now, if something I said suggested that would exhaust the ontology, then I apologize. I certainly didn't intend to say that. So why is suppose
So no, the problem is...
Let's think about quantum field theory. As Sean pointed out, we don't have an accepted, beable picture of quantum field theory. There's various candidates on, we learn how to do calculations of scattering experiments, and we need to say a bit more to actually get a picture of a world of objects from that. But suppose we do. Suppose, say, we extend some kind of Bohmian theory to quantum field theory, maybe because it's got particles popping in and out of existence, or maybe there's something like, instead of a mass density and energy, momentum density. My preferred, we have, a relativistic collapse theory with the basic local variables being energy and momentum density. Then I think of what I say about objects, as being entirely, conversant with that kind of picture. And I certainly didn't. I mean, I had that, abstract of that article on the size of the proton. Those are done by, scattering experiments. So whatever else we say about quantum field theory, we should be able to make sense of, the practice of, you've got something there, and it doesn't, it could be just a, somewhat localized field disturbance, but has a certain charge, and you do scattering, and then you have, detectors, which are things in three-dimensional space that fire. So, so it's not clear to me though why what I'm saying seems to be in tension with that.
Well, it's that we don't have that sort of story. I mean, you and Tim, and I guess in some sense all of us would love to have the story that makes modern physics sort of come back down to reality. We don't have it yet. And what I was objecting to more, though, is the idea that it's very clear that when we get that kind of story, the sort of Aristotelian talk of dispositions and powers and so forth is going to be the right reconstruction or the right gloss to put on that, as opposed to something that much more, say, refers to mathematical laws and sort of strips away the causal and power and dispositional oomph from the objects themselves, which is kind of the Humean spirit that partly was Lewis's inspiration. So that's my concern about your story.
We'll have to talk, because I don't know why there is something particularly Aristotelian about the way I was dealing with laws of powers and dispositions. I was, it was Newton that I was quoting, and I also, I mean, we have to talk, because yes, we express. If I say that, here's a scattering center, it's got a certain mass and charge associated with it, and what I mean is, a disposition to scatter things in various ways. Yes, those laws are expressed in mathematical terms, and if you want to say, okay, all there is are those laws, but no causal oomph, well, what is causal, I mean, except what, am I worried that you're attributing something, extra that I wasn't saying? If I want to say that, this table has causal, I don't mean anything more than the way it interacts with other things. I tend not use the phrase causal loop.
Okay, I think we should probably close the discussion there.